Alrighty, so we have looked at sine, cosine, and tangent ratios to find the missing side lengths of a rectangle. But what if we want to find a missing angle? So today we will look at how to use the side lengths and find the angle that's associated with it. Okay, so take a minute and work through 1 through 2 for me. Alright, so we talked about similar triangles. What relationships are true about the sides and angles of similar triangles? So the angles were congruent. And the sides scaled with a common factor. Okay. So also that sine, cosine, and tangent ratios were constant for fixed angle measurements. Alright, so what about for number 2? It says find each of the following missing parts of the triangle. Show your work or explain how you found the answer. Round to the nearest tenth. What is the length of side A? So I know this angle here. I want to find the side that's opposite, and I know my hypotenuse. So opposite and hypotenuse is sine. So sine of that angle measurement, 19.5, is going to be equal to your opposite side, which is A, over 9. So to solve for A, we'll say 9 times sine of 19.5, which is roughly what, 3? Okay. So what is the measure of angle theta? So here I want to find this angle measurement. I know the side that is opposite of that angle measurement, and I know my hypotenuse. Oops. So that's going to be sine of theta is going to be equal to 3 over 9. Okay. Well, you want to take basically the inverse of this value to get the theta out of there. So what you're going to say is inverse sine of theta, or inverse sine of 3 over 9. Sorry. So make sure your calculator is in degree mode, and what you'll push in your calculator is going to be second and sine. So when you do that, you get what, 19.5? Make sure you're in degree mode on your calculator. That's important. Alright, so what is the length of side W? So that's the opposite side. So this will be sine of 19.5. It's going to be W over 6. So W here will be 6 times sine of 19.5. So W would be what, 2.0? So now find the measure of the angle. So we have sine of theta is going to be equal to 2 over 6. So theta would be inverse sine 2 divided by 6. So theta here would be 19.5. So what is the ratio in the following triangle of the sine ratio for theta here? So opposite over hypotenuse, right? So sine of theta is opposite over hypotenuse, so it would be 5 over 15. So if I were to reduce this, it would be like what, a 1/3? And if you look at these ratios, 2 over 6 reduces to a 1/3, and 3 over 9 also reduces to a 1/3. So these are all similar triangles here. So what is going to be the measure of angle theta? Without doing anything, I know that it's got to be what, 19.5, because it's the same factors, it's the same ratio as both of these in 2, right? So sine is the same ratio as, what was that, B and D. But if you plug in your calculator, you would say what? Theta would be inverse sine of that ratio 5 over 15, which is going to be 19.5. Alright. Okay, so angles in a right triangle are determined by the ratio of sides in that triangle. So angles in a right triangle are determined by the ratio of sides in that triangle. Okay. So we'll have our, let's call this triangle A, B, and C. So that's going to be my theta down there. So this would be what, side A, side B, and side C. It's my right angle. So sine of that angle theta is going to be opposite over hypotenuse. But to find the angle measurement, it will be inverse sine of that ratio A over C. So cosine of theta is going to be your adjacent side, which is B over C. So in this case, it will be inverse cosine of B divided by C. And tangent of theta is going to be A over B, opposite over adjacent. So theta is going to be tangent, inverse tangent of A over B of that ratio. Alright, so take a second and work through numbers 1 through 5 for me. So find the measure of the missing angle here. So I'm going to let the question mark be theta. So I know my opposite side and I know my hypotenuse, so that's going to be sine. So that sine of theta is going to be equal to 11 over 27. So this will be, so theta is going to be equal to inverse sine of 11 over 27, which is going to be 24.042. Make sure you're in degree mode. We'll let that question mark be theta again. So I know the side that's opposite and I know adjacent, so that's tangent. So tangent of theta is going to be 9 over 21. So theta is going to be equal to the inverse tangent of 9 over 21, which is what, 23.199? Right? A hiker is walking up a mountain on a straight trail. So after walking 8 miles, she has gained 3 miles in elevation. So after she walks 8 miles, she has gained 3 miles in elevation. What is the angle of inclination of the trail? So how can I figure that out? So I know my elevation is 3, and I know how far I went was 8. So that's opposite over hypotenuse, which is going to be sine. So the sine of theta is going to be equal to 3 over an 8. So theta will be equal inverse sine of 3 over 8, which is what, 22.024. Right? In a right triangle, the hypotenuse is 2.5 times bigger than the side adjacent to angle A. Find the measure of angle A. Very interesting. So in a right triangle, so here's going to be my A, my angle A. The hypotenuse is 2.5 times bigger than the side adjacent to angle A. So the side adjacent to angle A is going to be B down here. So I don't know what it is, so we'll let that be X. But the side hypotenuse is 2.5 times bigger than that adjacent side. So that's how we would set up our triangle. So I know my adjacent side, I know my hypotenuse side, so I can find my angle A. So, oops, it's not sine, but what is it? It's cosine. So cosine of angle A is going to be equal to X over 2.5x. So what happens to the x's? They go away. We don't even need them. So to find angle A, I'll say inverse cosine of 1 over 2.5. So that's what, 66.422? Alright. So number 5 says find an angle where find an angle x, where sine of x is equal to cosine of x. So, an angle where they are going to be congruent. So sine is going to be what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. So technically I want to figure out where opposite and adjacent are going to be equal to each other. So that means that my sides have to be congruent, right? So what type of triangle am I going to be looking at? So here's my angle x. So my opposite has to be the same thing as my adjacent side. So if they're the same, then I'm going to be looking at an isosceles triangle. Okay, so in an isosceles triangle, I saw the sides are congruent. Okay, the two legs are congruent, so the angles are going to be congruent. So that means they're going to be 45 degrees. So x has to be 45 degrees. Well, let's check it out. What is sine of 45? If you plug this in your calculator, so sine of 45, make sure you're in degree mode, and cosine of 45, do you get the same answer? I do, right? So it's 0.707. It's going to be the ratio of 0.707. Good deal. All right, let me know if you have any questions.